Good day, students. Myself, RaviKrishnanPandey, professor in the Department of Computer Science and Engineering, will going to discuss here the Mealy and the Moore machine. This topic is covered in the Digital Logic Designing subject in the 4th unit. So, a Mealy machine is a finite state machine whose output depend upon the present state as well as on the present input. We will see it further in diagrammatic manner. So it can be described as 6 tuples Q, sigma, O, delta, psi, Q0, where Q is the finite set of states, sigma is the finite set of symbols called the input alphabets, O is the finite set of symbols called the output alphabets, delta is the transition function which can be described as Q cross sigma gives you Q, which means we can have a state Q over to which we will give an input alphabet, and this prominent expression gives you an output which will be from the set of Q again. Then psi is the output transition function which described as Q gives you output. Q0 is the initial state from where we have to begin the process. So the diagram is there. If we see that, let's suppose if we have given 0 to A, we will direct it to B. It's mean the output is B here, the state B is the output here, and A is your state, initial states on which we have given our input 0. So what happened when we given the input 0 to state A, we will have an output B as a state. And if you give 1 to a state A, you will have an output state C. So here the output is dependent upon the current state as well as the input provided on the current state. Whereas if we come with the Moore machine is also an FSM, finite state machine, whose output is solely dependent upon the present state. If we see the description of the Moore machine, it has the same description with the 6 tuples. All the units are same. Q is the finite set of states, sigma is the finite set of symbols called input alphabet, O is the finite set of symbols called the output alphabets, transition function which is described in the same manner, and psi the output transition. Here the output transition is Q cross sigma gives you O. So let's have a look over to the diagrammatical manner of the Moore machine. So this is the Q0 is again here the initial state from where I have to begin. See, the diagram is little bit different from the other diagram we have seen. So what is the difference here? The states have a particular output inside them. It's mean whether you are applying 0 on A or 1 on A, the output is not dependent on the input you provided on the states. Whereas here the output of the A state is already fixed, which is written inside the state only. So that is the main difference between the Mealy and Moore. Let's see the more differences. So come to next. So as we have gone through that output of the both depend upon the state and present state. Is it in Mealy machine, and whereas in Moore the output depend upon the present state only. Come to the Mealy, generally it has fewer states than the Moore machine, and the Moore one have the more states in comparison to Mealy machine. With concern with the Mealy machine, the output changes at the clock edge, whereas in Moore the input change can cause change into the output change as soon as the logic can done. With Mealy machine react to faster to the input, whereas the Moore logic needed to decode the output since it has more circuit delay. So that's a very brief gist between the Mealy and Moore machine. I suppose that you will have a better understanding of the topic. So I'm just closing it. Thank you very much.